Hello everyone, my name is Oleksandr Ovcharuk and today I would like to introduce our work, a method for post-traumatic stress disorder manifestation analyzing in text content. This work is especially relevant in today's world because post-traumatic stress disorder is debilitating mental illnesses that affect approximately 10% of the population. With the development of digital technology and social media, a new opportunity has appeared to study the manifestation of PTSD through the analysis of user content. Analysis of user content, such as messages in social networks, blogs, forums, and comments, allow to obtain unique insight into the emotional and mental state of victimism. The application of machine learning and natural language processing method to detect signs of PTSD in user text is a modern and promising direction of scientific research because it can not only identify individual cases of PTSD but also help in the development of preventive measures and support program for persons who are at risk. The main goal of the paper is to create the method for post-traumatic stress disorder manifestation analysis in user text content, which differ from existing ones by focusing on context dependencies specific to PTSD, which help to avoid confusions with other mental illnesses, achieved by creating its own training dataset, as well as by using separated positional embeddings to take into account the position of word in the text, which improves the accuracy of the model. The main contribution of the paper can be summarized as follows. The method for post-traumatic stress disorder manifestation analysis in text content has been developed. The set of training data was created, which allows focusing the attention of the neural network on PTSD, while reducing its confusion with other mental disorders due to inclusion of training text with manifestation of other mental disorders in the orthogonal category. The effectiveness of using the development method has been extremely proven, which allows, unlike existing analogues, not only to detect PTSD but also to show visual interpretation of obtained result. The proposed approach to solving the problem of detecting manifestation of post-traumatic stress disorder in user text content is shown in the figure. The approach demonstrates the transformation of input information in the form of text content for analysis and trained content-oriented neural network model with tokenizer into output information in the form of a percentage of manifestation of post-traumatic stress disorder in user content. At the first stage, preprocessing and tokenization of text content is carried out. The context is checked for length and not emptiness. However, punctuation marks emoticons and the rest of the text features are retained as they may carry additional relevant information that indicates the percentage of PTSD. Tokenization is carried out by tokenizer on which a natural network was trained. At the second stage, natural network analysis of the manifestation of post-traumatic stress disorder in user content is carried out for the detection of which content oriented neural network was transformed, architecture will be used. As content-oriented neural network, the DeBarta model will be used, the architecture of which is shown in this figure. The DeBarta neural network model is characterized by the presence of 5 layers sets, embedding, encoders, pooler, classifier, and dropout. The proposed method of detecting PTSD in text data is shown in the figure. According to the scheme described in the figure, is the first necessary to prevent working data. A balanced set of data is fed to the input of the natural network for further training. At the same stage, the dataset is vectorized and divided into training and validation samples in the ratio of 80% to 20% respectively. Also, training parameters are set here in the form of batch size and number of epoch. After completion of the retraining process of the natural network of the transformer architecture, the efficiency of the model is evaluated accordingly to the following metrics: accuracy, precision, F1, AUC. After the metrics are divided, if their results are satisfactory, over 80% for each matrix, the model and tokenizer are saved. The last step is to explain the decision obtained with the help of the training natural network transformer. For this purpose, model explanation tools designed for working with transformer architecture natural network will be used. The effect of improving the analysis of PTSD manifestation accordingly to the proposed approach is shown in the figure. In particular, by using a relative position shift instead of the absolute one, it was possible to achieve an increased focus on PTSD-specific context dependency. By using dispersion estimation, it was possible to analyze context dependency at different distances by improving a separate execution of the attention component for the world and for the position of the world. It was possible to perform the analysis complexes, dependencies, and contexts that are inherent in the manifestation of PTSD in the text, by including text with manifestation of other mental disorders in dataset. It was possible to improve the separation from manifestation of other mental diseases. The dataset from SHAM is shown in this figure. Since there are no open dataset with enough data to training the neural network. A composite dataset was formed based on the existing human stress prediction and IA-PTSD datasets. In order to study the effectiveness of the development method of analyzing the manifestation of post-traumatic stress disorder in text content, the corresponding software was created in the form of a notebook in Google Colab cloud environment. As a pre-trained natural network of the transformed architecture, there was selected the Berta version 3 model from the huge phase. A resource was taken. This model was retrained on the dataset created and described above 3 epoch. In general, the trained model was tested on the validation samples, which shows the following metrics value: accuracy 0.934, precision 0.948, F1 0.841, AUC 0.872. The ROC curve was evaluating the quality of natural network learning is shown in the figure. As can be in a figure, only 10 entries in the PTSD class out of 20 220 were identified as having no manifestation. However, 24 records out of 220Z didn't have PTSD, were falsely identified as PTSD. Also, given the compression with similar studies, these results are good. The development method allows not only to effectively analyze the manifestation of post-traumatic stress disorder in the user content and to provide an explanation of decision made. An example of the interpretation of the model's decision about the presence of PTSD in the text is shown in the figure. According to figure, the following text is indicated of PTSD as it contains a sense of doom and phrases such as doom to my gloom indicated a high level of anxiety and worry. As part of the research, it was also analyzed how the model processes and interpret different parts of text. This especially useful for diagnosis and improving model. Using the tools BERT with, the visualization show the attention weight for all layer and all heads in each layer. An example of illustration of such mechanism is shown in a figure, where attention weight displayed in color, the brightness, the color, the grade, the influence of these context dependencies on the final arousal. And conclusion and approach to solving the problem of detecting manifestations of post-traumatic stress disorder in user text content is proposed. The approach differs from existing ones by increased focus on PTSD-specific context dependencies and improved separation from manifestations of other mental illnesses. Increasing focus on PTSD-specific context dependencies is achieved by using separated positional embedding to account world position in text, improving model accuracy. The application of machine learning and natural language processing method to detect signs of PTSD in user text is a modern and promising direction of scientific research because it can not only identify individual cases of PTSD, but also help in the development of preventive measures and support program for persons who are at risk. The proposed approach allows not only to determine the manifestation of post-traumatic stress disorder in text content, but also to visualize, interpret the obtained result. The development method effectiveness was investigated by developing the appropriate software when training natural network of described architecture. The following metrics were obtained: accuracy 0.934, precision 0.948, F1 0.841, AUC 0.872. Further research will be aimed to expanding the dataset for training and finding additional label in text characterizing PTSD, which will make the decision of natural network model more understandable and will make it possible to more accurately identify of manifestation of PTSD in text content. Thank you for your attention.